All right, these are the answers to our test review. We got a dot plot here, and it says what number of goals describes the center of the data, just by visually. So you kind of look at here, maybe you pick somewhere in the 5 to 6 range, or maybe you went with the highest one. This is just your eyeball test, right? So just by looking at it, I would say that we're probably somewhere around 5, okay? But again, this is just a guess. We aren't really sure at this point. So now we're gonna find the median of it. So if I count off, there were 12 games, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I have 6 games on this side, 6 games on that side. My median is halfway between here, so the median would be 4.5. Okay. What's the range of goals? Well, the highest number was 13. That's our maximum. And our minimum was 1. So 13 minus 1 gives us a range of 12. Okay, so always do max minus minimum. That'll give us our range. Describe the shape of this. Well, we're kind of going up, and then we come down and we trail way off to the right. So I would say that this is skewed right. And because it's skewed right, that means the mean is bigger than the median. All right, so I'm expecting the mean to be something bigger than 4.5. But let's actually figure it out. So for the mean, we're gonna add up the total number of goals. There's 1, then each of these games were 3. So 1 plus 3 plus 3 plus 4 plus 4 plus 4 plus 5. And you just keep doing that, all right? So let me just kind of do that real quick. 7 and 12, 19, 24, 38, 48, 60. I get 73 total goals, and there were 12 games. So I'm gonna go 73 divided by 12, and our mean is 6.08. So just like we expected, the mean is much bigger than the median because of this skewed rightness here. Okay, so whenever we have something that's skewed right, these numbers over here are gonna push the mean to be bigger than that, okay? All right, then this one's kind of a little extra. Just wanted to see if you could figure some stuff out. It says Frank wants to have a bowling average of 215. His first 7 games he scored this. What must he score in the 8th game to have an average? So in order for him to have an average of 215 for 8 games, we're gonna go 215 times 8. All right, and that means 215 times 8, he needs to have a total score of 1720. That's the total. So what we're gonna do then is we're gonna take 1720 minus the total of the 7 games that he's done, all right? So in other words, I'm gonna take the 159 plus 182 plus 225 plus 240 plus 198 plus 200 plus 230, and that's 1434. So we're gonna go 1720 minus 1434, 1720 minus 1434, and he needs to bowl a 286. That's hard to do, but not impossible. 300's the most you can get. So, but it's gonna take a big effort, all right? Now, our son says data A has a standard deviation of 15, but data set B has a standard deviation of 5. So this is a bigger standard deviation. That means they're more spread out, all right? So put A here and B here. It says, can you draw either a dot plot, box plot, or histogram of each? Well, we'll start with a dot plot. So a dot plot for A, when it's more spread out, might look like this, where the data really has kind of a big spread to it, okay? Whereas B, the data is really close together. So B might look something like that, where all the data is pretty tight together, whereas A, it's more spread out, okay? That would be an option for a dot plot. For a box plot, again, A might have something where the things are a little more spread out, okay? So something like that. Whereas B, it might be really close together, okay? So the bigger the standard deviation, the more spread out it is. For a histogram, same idea. You know, we might have a box here and then another one here and another one here, and we're really like spread out with the data. Whereas for B, maybe it's just a few, and we're really, really close together, something like that, okay? Again, bigger the standard deviation, the bigger the spread. All right, so then we get this histogram here. It says how many people above between 20 and 30 went to the festival. It looks, we're just about at that 20 mark. I'd say about 20. If you went a little higher, I wouldn't argue with you. How many 34-year-olds? Again, 34 is in this category. We don't really know. It looks like it's somewhere maybe just around 38-ish or something like that. So no more than 38, but we're really not sure because we don't know for sure what the individual ages are in there. How many people under 30 were there? Well, we had 20 in this group, and then we have about 25-ish maybe, so I'd say 45. Again, if you had a different estimate on those, I wouldn't argue with you. How would you describe the shape of the distribution? This is pretty symmetrical, pretty mound shape. I don't think there's a skew to it. I would say mound shape for this. Again, we're not skewed all over the place on there. And would you say this has a high standard deviation or a low one? Again, this isn't, I mean, the data is kind of spread out. We're going from 10 all the way to 60. We're not really seeing that bunch. I think in this case, if I had to pick, I'd say a high one. Probably not, but not too high. All right. But that would be my guess on that one. Okay. All right, then the box plot. We're given some numbers here, and we're asked to find the 5-number summary and whatnot. So in order to do that, we have to put them in order first, all right? So I'm looking through here. I see 26. That looks like the lowest one. Cross that off. All right, and then I have a 28. All right, check, see, do I have any other 20s on there? Oh, there's a 24. I'll put that before, okay? Check and see. Nope, doesn't look like that. All right, so for 30, we have a 30 there. All right, we have a 32. We have a couple 33s, it looks like. Okay, and then that looks like it. Then we have some 40s. And we have 42. We have a couple, actually. We have 1, 2 44s. We have 3, 4, oh, we have 4 45s. Get 4 on there. All right. Then we have 2 52s and a 66, it looks like. All right. So we've gotten through all of those there. Put them in order. So our minimum is 24. Our maximum is 66. Okay. As far as the median goes, let's see, we had 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 20 numbers here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Between 42 and 42, that means our median is 42 for that. Okay. So Q1 is the middle of this group. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Between 32 and 33 is 32.5. That's Q1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Between 45 and 45 is 45. IQR is Q3 minus Q1. So that's 45 minus 32.5. That's 12.5. That's IQR. Okay. So for the box plot, do this here. Let's go 20, 30, 40, 50, 60, 70. All right. 24, we're going to make a little dot line there. 66, we'll make a line there. 32.5, 42, and 45. All right. Connect the middles with a box like that, and then draw a line out to the edges there. All right, 25% of our data is right in here. 25% of our data is right here. 25% of our data is here. And 25% is here. So even though it looks big, it's the same amount of data, same numbers. Amount of numbers are here, they are here. So this is more spread out versus this where those numbers are pretty close together. And you can kind of see that up here. See how those numbers are pretty close together, whereas this one goes from 45 all the way to 66. So don't get fooled into thinking there's more numbers in there. There aren't. It's just the way it is. All right, now we have two different things given to us, and we're supposed to figure out whether these things are true or false. So this says 50% of the time, battery X has less than a 13-hour battery life. You can see that 13 is right there at the middle of this, so 50% of the time it's under that. This is a true statement. Okay. Every battery of brand Y lasts longer than every battery of brand X. That's not true. There's plenty of batteries here in brand Y that don't last as long as that, so that's a false statement. A lot of them do, but not all of them. Brand Y lasts 15 hours or more 75% of the time. So here's 15 hours, and you can see we have 1, 2, 3. So this 25%, this 25%, this 25%, all are bigger than that. That would be a true statement. We know that at least one battery of brand X lasted exactly 12 hours. So we do know that there's a dot there at 12, but we don't know if there was a battery that did that or if that's halfway between two things. It's saying too much to say that that happened that way, so we'd have to say false for that. The best battery of brand X is at the 50% level of brand Y. Here's the best battery of brand X, and there's the 50% for Y. That's a true statement. The middle 50% of Y lasts between 15 and 17 hours. The middle 50%, so that's this box here. This is the middle 50%. It's between 15 and 17. That would be a true statement. The standard deviation of X is bigger than the standard deviation of Y. Standard deviation is how spread out are you? And you can see that brand X only goes from here to here, whereas brand Y goes from here all the way to there. I would say that's probably a false statement. 75% of brand Y batteries last longer than 75% of brand X batteries. So 75% of brand Y, which is right here, lasts longer than 75% of brand X. That's pretty easy to see that that's true. Very good. All right, then two-way tables. It says, what percent of people surveyed are from Milwaukee County and have not been to the Dells? So Milwaukee County and have not been to the Dells, that was 45 people, 45 out of the 465, okay? So the best way, I think, to make that a percent is just to go ahead and divide it. So go 45 divided by 465. We get 0.097, which is 9.7%. You just move the decimal 2 spots, and that's all you have to do then. Okay. What percent of people surveyed have been to the Dells but do not live in Milwaukee County? So have been to the Dells but don't live in Milwaukee County. That's 140 out of the 465. Again, we're going to do the same thing. We're going to go 140 divided by 465, and that gives us 0.301, which is 30.1%. Okay. What percent of people surveyed lived in Milwaukee County? So of the total, there were 245 people that lived in Milwaukee County out of 465. So if we go 245 divided by 465, we get 52.7%, 0.527, 52.7. All right, knowing that someone has been to the Dells, what's the probability that they do not live in Milwaukee County? So knowing that someone has been to the Dells, so we're only looking at this column here, okay? What's the probability that they don't live in Milwaukee County? Well, there were 140 out of those 340 that didn't. So we're gonna write 140 out of 340, and if we divide that out, we get 41.2%.